In this video, we're going to review what the surface area of a three-dimensional shape is, create the net of a shape in order to calculate the surface area of a three-dimensional shape, and use the correct units of measurement for that surface area. Surface area uses many of the other processes that we've covered in this course, and whilst the concept of finding the surface area of a shape is not very complicated, it does involve several other steps that you may wish to review first. I'd like to recommend that you watch the area and perimeter video to have a good idea about how to calculate area. Watch the video on 3D shapes to understand how to create the nets of the 3D shapes. And lastly, to look at the circles video so that you're confident to work with pi and find the area of circles. All of these skills are going to be used during this video. Here we have a cuboid measuring 12 centimeters by 7 centimeters by 8 centimeters. If we were to unfold it, we'd get this net, meaning a two-dimensional representation of the faces of the shape. In order to better understand how these make up the shape, we'll label them. The 12 centimeter by 7 centimeter rectangle is the base, and therefore this one must be the top. That would make this one, that is 8 centimeters by 12 centimeters, the front, and the opposite one being the back here. This 8 centimeter by 7 centimeter rectangle will be the left, and the right one will be here. In order to calculate the surface area, you simply work out the area of each of these shapes and add it together. As this has matching sides, we can find one of each, add them together, and then double it, knowing there's a second side the same size to a total of all 6 sides. So the base will be 7 times 12 to give 84 centimeters squared, the front is 8 times 12 to give 96 centimeters squared, and the left is 8 times 7 to give 56 centimeters squared. If we add these together, we get 236 centimeters squared and multiply it by 2 to get 472 centimeters squared. It's a good time to note that we're using centimeters squared with this measurement because although it's a 3D shape, we're looking at the two-dimensional shapes that cover the outside of it. As we'll see throughout this video, unfolding and getting the net of a cuboid is key to working out the surface area of any three-dimensional shape. In the next slide, we have a triangular face prism. If we unfold it, we'd have the following net. We'll label these to show the base, the left side, the right side, the front and the back triangles. We need to calculate the area of each of these in order to add them all together to get the surface area. Let's start with the left rectangle. 10 times 5 would give 50 centimeters squared. The base rectangle, 6 times 10 to give 60 centimeters squared. And now the front triangle. 6 times 4 divided by 2 to give you 12 centimeters squared. As we have 2 of the triangles, we can multiply that by 2 and get 2 times 12 equals 24 centimeters squared. We also have 2 of the same rectangles, which make the left and the right side. So 50 times 2 would give 100 centimeters squared. Now we can add all these sides together to get 184 centimeters squared, which is the surface area for this shape. It's important to remember that we're just creating the net, calculating the area of each shape, and then adding them together to get the surface area. Now we've got a square base pyramid, and if we open it up, we get this net. To calculate the area of the base, we should recognise it as a square and multiply 6 times 6 to give us 36 centimeters squared. Each of the triangles are the same height and base. We can calculate one of them and then multiply it by 4. So 6 times 4 divided by 2 will give you 12 centimeters squared, and we can times that by 4 to get 48 centimeters squared. This is the total area for all of the triangular sides. If we add this to the base, we'll get the total surface area. 48 plus 36 will give us 84 centimeters squared. So we can double check that we've got all the sides of the shape and be confident we've calculated it correctly. Next, we're going to look at how to do this with a cylinder. So we're going to find the surface area of this cylinder. If we were to open up this cylinder, we'd end up with 2 circles, one at the top, one at the bottom, and a very long rectangle. The reason for the length of this rectangle is it will be just over 3 times the diameter of the circles, as it will be the same length as the circumference of the circles at either end. The width of the rectangle is going to be the same as the height of the original cylinder. So let's start by creating the area of one of the circles, and we know that the area of a circle is pi times the radius squared. So pi times 4 squared will give us 16 pi. We'll times that by 2, as there's 2 circles, to give us 32 pi, or 100.53 centimeters squared, after we press the SD button. This will be the area for both of the circles. Now to calculate the area of the rectangle. In order to do this, we need the length, which we know is equal to the circumference of the circle. So we can calculate it as pi times 8, which is the diameter, which will give us 8 pi. To get the area of the shape, we can then do 8 pi times 20 centimetres, which is the width of the rectangle, which will give us 160 pi, or 502.65 centimetres squared. If we add these two totals together, we get an overall total of 603.19 centimetres squared. I've rounded this to 2 decimal places because we haven't specified the degree of accuracy to put it to, and if I'm in doubt, I always just round it to 2 decimal places. Lastly, we're going to find the surface area of a cone, and we've been given the formula for finding the area of the conical shape and then told to add it to the area of the base to get the total surface area. The formula for finding the conical shape, or the minor sector, which is what it looks like if I open it up flat, is pi times radius times length of the side from base to tip. So in this situation, it's going to be pi times 4 times 8.5, which will give us 34 pi, or 106.81 centimetres squared. If we now work out the area of the circular base, which is pi times 4 squared, or 16 pi, or 50.27 centimetres squared, we'll get the total surface area by adding those two together to get 157.08 centimetres squared. And that's the total surface area for this cone. In this video, we reviewed what the surface area of a three-dimensional shape is by opening up the shape and creating a net. We then calculated the area of each face in that net, added them together to get the total surface area for the shape. We then remembered to use the correct units of measurement as we're finding the area of a 3D shape and not its volume. In the next video, we'll be looking at transformations and how we go about moving, enlarging, rotating, and reflecting shapes on an X and Y grid. I'll see you then.